fifth grade. We're back again for week number 31. We're getting close to the end. We're in our last quarter, so we're just starting the fourth quarter this week. So I need you to really be pushing hard to finish out this quarter strong, because this is the end of your fifth grade year and you'll be moving on to sixth grade next year. So I need you to be working super hard to make sure that you are understanding all the work that I've been giving you. So we're going to start with a new module. We're on module 9, lesson 1, and it starts on page 217. And we're going to be exploring area and mixed numbers. So this is all about area with fractions and mixed numbers. So you're going to be able to use an area model to multiply mixed numbers. So to begin, Ms. Cruz wants to use square tiles to cover the front entryway of a house. Each tile she plans to use measures 1/2 foot by 1/2 foot. What is the area of the entryway? So we're going to draw a visual model to show how many tiles she will use, and then we will explain how we can use our visual model to find the area of the entryway. So our very first step is we see we have mixed numbers, and mixed numbers are going to be difficult. Well, we can't do 3 and then a half, right? Because each tile is going to measure 1/2 foot by 1/2 foot. So the first step I want you to do is I want you to take your mixed number and I want you to convert it into an improper fraction. And how we do that is if we have 3 and 1/2, we're going to change it to an improper fraction, which means you're going to multiply your whole number by your denominator. So 3 times 2 is 6, and then you add your numerator, which is 7. So you have 7/2 by, so now our 4 and 1/2, we're going to convert into an improper fraction as well. 4 times 2 is 8, plus 1 is 9/2. So now I know how many I need to do on each side. So I know, because each one is 1/2 foot by 1/2 foot, if I have 7/2, that means I have 7 going across. So 1, 2, 3, 4, 5, 6, 7. So this is our 3 and 1/2. And then I need my 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it tells me exactly how many I need to go down and how many I need to go across for my 4 and 1/2. So I'm going to come down, and here's my rectangle. Now, I want to cross 7, right, because this is the same as 7/2, and I went down 9. So that's 9/2. So when we find the area, what is the formula for area? Because remember, the question was, what is the area of the entryway? The formula for area is length times width equals area, right? Our length times our width. So if our length is 7/2 times our width, which is 9/2, 7 times 9 is 63. 2 times 2 equals 4. So the area of this rectangle of the front entryway is 63/4 square feet. We need our label. So first you have to take your mixed number, convert it into an improper fraction, then you know your dimensions. Okay? Mixed number, convert it into an improper fraction, gives you your dimensions. So it's going to give you your length and your width, and then you know what you need to multiply together to find your answer. Okay? So 63/4 square feet. Alrighty. Next one, page 218. So Will is going to replace the tiles of a shower floor. The floor measures 4 1/3 feet by 3 2/3 feet. Will covers the floor with small square tiles. Each tile he uses is 1/3 foot by 1/3 foot. Use the grid to represent the shower floor. Each square represents one tile. So, again, I'm going to take my 4 1/3 and I need to convert it into an improper fraction. So I multiply my whole number by my denominator. 4 times 3 is 12. Then I add my numerator. Plus 1 is 13/3. Then I have my 3 2/3 feet. 3 times 3 is 9. Plus 2 is 11. So we have 11/3. So one side of the tile floor is 13/3. The second side is 11/3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, all the way to the end. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's the tile floor. Now I could count all those squares in there, right? I mean, it would work. However, we have a math formula that we can use, right, to find the area. So we've got 4 1/3 or 11/3, or 13/3, I apologize. I was looking at the wrong one. And then we have 3 2/3, which equals 11/3. So to find out how many tiles cover the shower floor, we're going to take our 13/3 times our 11/3. Now again, you could count them. That's fine. But personally, we have some math that we can do. So 13 times 11. 3 times 1 is 3. 1 times 1 is 1. Bring down or put a 0. 3 times 1 is 3. 1 times 1 is 1. 143/3. So there are 143 1/3 by 1/3 foot tiles. And that's how we can find the number without counting them, right? We just have to multiply 11 by 3. Or 13, sorry. So the area of each tile would be 1/3 by 1/3, right? So how do we find, how do we find the area of each tile? 1/3 by 1/3. 1 times 1 is 1. 3 times 3 is 9. So 1/9 square foot. So how can you use the area of each tile to find the area? Oh, I'm sorry, this was supposed to be a 9. Area of each tile to find the area of the shower floor. You're going to multiply the area of one tile by the number of tiles. Or you can multiply 13/3 by 11/3. (13/3 times 11/3), which is going to give you 143/3. So the area of the shower tile is 143/9. My goodness, why do I keep not doing that? And it would be square feet. 143/9 square feet. All right, now we have a map. So you can use an area model to multiply mixed numbers. So instead of rewriting your mixed numbers into improper fractions, you can also use the area model to find out what your area of the shape is, especially if you have different units for your fractions. So like the unit for this would be in halves, and the unit for the width would be eighths. So the units are different. So using the area model, especially when your units are different, is going to be a huge help. So how could we rewrite each mixed number as the sum of a whole number and a fraction? So if I had 1 and 7/8 feet, I would have 1 plus 7/8, right? Because 1 and 7/8 would be 1/7/8. And then if I have 2 1/4, 2 plus, or I mean half, 2 plus 1/2. Those are our two measurements. So now we're going to use this rectangle to do an area model. So remember when you were learning the area model last year in 4th grade, you would break up your rectangle into 4 pieces if you had a 2-digit by a 2-digit number. You're going to use that same strategy because you have a whole number and a fraction multiplied by a whole number and a fraction. So you're going to again break this up into 4 pieces. Remember, we always offset it because this is going to be your largest section, your next largest, and then your smallest down here. So I have 2 and 1/2 feet, right? This line, here's my and. On this side, I have 1 and 7/8 feet. So remember, when we have rectangles, the opposite sides are the same length. So if this side of the rectangle is 2, this side, the opposite would be 2. If this side is 1/2, the opposite is 1/2. And the same over here. If this is 1, this would be 1, 7/8, 7/8. So that's going to help with your multiplication. So in here, the big part, remember, the area is length times width. So you're going to multiply 2 times 1, which is going to equal 2. You're going to multiply 2 times 7/8. So remember, 2, a whole number, this would be over 1. So 2 times 7 is 14/8. We have 1 times 1/2. So it's like saying it's by its, or multiplied by itself, right? So that's going to equal 1/2. And then down here we have 7/8 times 1/2. 7 times 1 is 7. 8 times 2 is 16ths. So we just put the equations inside here. So I'm just going to put an arrow instead of writing them down. I wrote them inside the rectangle. So how could we use the areas of the 4 rectangles to find the area of the map? Well, we're going to add them together, right? Because remember, that's how you find the area. Once you do your multiplication, then you have to add your totals to find out what the area is. So add the areas together. And then the area of the map, so we've got 2 plus 1/2 plus 14/8 plus 7/16. Now look at all those different denominators, right? So we need to convert, we need to find some equivalent fractions to help us add this together. So I'm going to keep my 2, right, plus. Now I need to convert 1/2 into 16ths because 16 is what 2, 8, and 16 all have in common. So to convert 1/2 to 16ths, I'm going to take my 1/2 and I'm going to multiply it by 8/8, which will give me 8/16ths. Because 8/16ths is an equivalent fraction to 1/2. Then I need to convert my 14/8, and I'm going to convert that into 16ths. But first I'm going to pull out my whole number. So if I have 14/8, I've got 1 and, what's 14 minus 8? 6/8, right? So I need to convert my 6/8 to 16ths. So if I multiply the top and the bottom by 2, I would have 1 and 12/16ths. And then my 7/16ths. So if I add my whole numbers together, I have 3. Add my fractions together, I have 27/16ths. Now again, I need to convert this, change this from an improper fraction to a mixed number. So I'm going to pull out one whole, which is my 16/16ths. And then 27 minus 16 is 11. So I'm going to add my whole numbers together, so I will have 4 and 11/16ths. So there's lots of steps to this, but it all works, right? It all works if you use your area model. The other way to solve it could be 1 times 8, right, is 8 plus 7. So you would have, 15/8 times 2 times 2 is 4, plus 1 is 5/2. So that would be over 16. 15 times 5. You'd have 75/16. So we need to figure out how many 16/16 can we take out of here. So 75 divided by 16 would be 4, right? 4 times 2 is 24, 64, and there's your 11/16. Same as 4 and 11/16. So see how that answer matches this, right? So you could do it both ways. Okay? So I know it's a kind of a new, it's not really a new strategy because you used it last year when you did area model, but it's a new strategy when you're talking about fractions. Fractions are a whole different beast. All right. Pat cuts fabric for the back panel of a jacket. He measures it to be 1 2/3 feet long and 1 1/3 feet wide. He represents the area on a grid. The side lengths of each small square in the grid represent 1/3 foot. What is the area of the panel? So again, let's figure out how many we need along the side. So we need 3/3 and 2/3. So I need 5 on one side. And I need 3/3 and 1/3. So I need 4 on this side. So I have 5/3 by 4/3. So 5/3 times 4/3 equals 20/3. Oh, sorry, 29ths. I do that every time. I don't do it with the other ones, but for some reason 3 times 3 I can't get out of my head. So it'd be 20/9 square feet. And if you want to convert it into a whole number and a mixed number, or and a fraction, you would have 1, 2, that's 18 and 2/9. So it was the same as 2 and 2/9 square feet. But you can just leave it at this. I'm just showing you if you wanted to do change the improper fraction to a mixed number. Okay, we're going to use this rectangle to draw an area model, and then we're going to solve. So just like we did up here in the blue. So we have, I got numbers up here. So I don't want that to interfere. So we're going to do this, just so it doesn't interfere. So we have 2 and 1/3. 3 and 1/2. 2 and 1/3, 3 and 1/2. So in this big square, 2 times 3 is 6. And this little square, 2 times 1/2 equals 2/2, which is 1 whole. 3 times 1/3 is 3/3, which is 1 whole. And 1/3 times 1/2 is 1/6. So we have 6, 7, 8, and 1/6 is the area of that rectangle. Alrighty, last page. Remember, this is the on your own section, so if you want to do it independently, pause the video and come back and check, or stay right with me. So we're going to use the grid to find 1 1/4 times times 3 1/4. Each square is 1 4/4, or 1/4 by 1/4. So this would be 4/4 plus 1/4 is 5/4. So I'm going to go down for 5. 1, 2, 3, 4, 5. And then we have 3 of the 4/4, so that would be 12, plus 1 is 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh no, I didn't do it long enough. All right, let's just add an extra square in here. I know it's not the same size. And then we come over here. So this would be our 3 1/4, which is the same as 13/4. And this is 1 1/4, which is the same as 5/4. So if we multiply 13/4 times 5/4, 13 times 5, 65. 4 times 4 is 16. So 65/16 square feet. Use the rectangle to draw an area model to find 2.5 by 4 2/3. Okay. So we've got 2 1/2, 4 2/3, 2 1/2, 4 2/3. 4 times 2 is 8. 4 times 1/2, we have 4 over 2, which is the same as 2. 2/3 times 2, which is 4/3. And then 2/3 times 1/2 equals 2/6. So we're going to add 8 plus 2 plus 4/3 plus 2/6. 8 plus 2 would be 10. We're going to regroup this. So we'll have into sixths. So our 4/3 will become 8/6, because you're going to multiply the top and the bottom by 2. So 8/6 plus 2/6 is 10/6. So then if we break this one apart, we're going to have a 6/6, which is the same as 1 whole, and 4/6. So we'll have 11 and 4/6. And we are going to skip the open-ended. So on your 9 point, sorry, I was thinking about 4th grade. On your 9.1, you're going to complete 1, 2, and 3. You can skip number 4. And then you're going to do the back. Okay? So just skip number 4, but you can complete the rest of the work. Okay? So go ahead and do that, and when you are finished, send it into school to me. All right. Have a great day. Bye.